Hey guys, how you doing? Hope you're doing fine. I'm doing fantastically. Just had a handful trail mix. So I'm ready to solve this improper integral right here. So in order to check if this is improper, first we need to check if the denominator is ever equal to 0. And we do that by making the quadratic equation right here equals 0. And then you can solve this using the quadratic formula. Minus b plus or minus b squared minus 4ac over 2a, which gives us minus b minus 1 plus or minus b squared, 1 squared, which is just 1, minus 4 times a, which is 1, times c minus 2, over 2a, 2 times 1, 2, which gives us minus 1 plus or minus root 9 over 2. Root 9 is 3, so it's minus 1 plus or minus 3 over 2, which gives us minus 1 plus 3 is it's 2 over 2, so it's 1, 1, or minus 1 minus 3 over 2, which is minus 4 over 2, which is minus 2. As we can see, minus 2 is outside of our range here, so the only time when the denominator is 0 is when x is equal to 1. So that is when our integral is undefined. And then we're going to have to split up this integral at this point. So let's do that now. So this is undefined when x equals 1. So we have to split it up at that point. So we get two integrals instead of one, from 2 to 1. But since it's an improper integral, I'm just going to replace the 1 with a constant. You can just use a, you can do any constant. Dx x squared plus x minus 2 plus from a to 0 dx x squared plus x minus 2. And you can see we split it up at 1 to get two integrals, so this should eradicate the problem. Maybe the integral converges, but it might still diverge. And now, the best way to integrate this is to factorize the denominator and then split it up into two terms. I'll show you how to do that here. So we'll just take the denominator. I don't want to write out the integration curves every single time. So as before, we got the solutions that x equals 1 and x equals minus 2 for the denominator. So we can factorize that. 1 over x minus 1 times x plus 2. And now this is equal to this. And now we can split it up into two fractions, which is going to help us to integrate it much easier. And we do that by writing it like this. So a over x minus 1 plus b over x plus 2 equals 1 over x minus 1 times x plus 2. If on the denominator there were, for example, a higher power of x, then this would be different. But in the case of the power of x being 1, then you can just do a and b. And then we multiply a by x plus 2 and b by x minus 1, make them equal to 1. Then we can work out what a and b respectively are. And then we can get this form. All right, so let's do that. So a times this, so we get a x plus 2a added to b times this, so plus bx minus b equals 1. And now we can see that on the right side, we don't have any terms of x, which means that a x plus bx equals 0, which means that a equals minus b. And from the rest of the terms that don't have an x in them, 2a minus b equals 1. 2a minus b equals 1. And then we can sub in minus b for a, which gives us 3, which gives us 2a plus a equals 1, which is 3a equals 1, gives us that a equals a third. And since a equals minus b, b is equal to minus 1/3. And now we can put these constants back into our fractions to get the split form. So our two fractions are going to be 1/3 over x minus 1, which is 1 over 3 x minus 1, plus minus 1/3 over x plus 2, which is just minus 1, 3 times x plus 2. And now this is much easier to integrate. So let's do that now. As from before, we have split this into two integrals, but I'll just do it with one and then we can put it into the two. So just to save us writing out some dx's and integral curves. So here we can take the 1/3 constant out. 1 over, and I'm also going to just straight put it into exponent form. So 1 over x minus 1 is just brackets x minus 1 to the power of minus 1. So we get x minus 1 to the power of minus 1. And I'm going to do the same with the next one. So 1/3 has come out. It's a minus x plus 2 to the power of minus 1 dx. And since the x within the bracket is to the power of just 1, we can integrate this into ln x minus 1 and this into ln x plus 2. So we get 1/3 ln x minus 1 minus ln x plus 2 plus the constant of integration. But since we're going to be calculating a definite integral, then this disappears. And now let's sub this into our original two integrals and compute the answer with the limit. And so we get our original two integrals split at a dx over x squared plus x minus 2 plus integral from a to 0 dx over x squared plus x minus 2 is equal to 1/3 ln x minus 1 minus ln x plus 2 to the boundaries of 2 and a plus 1/3 ln x minus 1 minus ln of x plus 2 to the boundaries of a to 0. So now let's put in the boundaries. So we get 1/3 ln 2 minus 1 minus ln 2 plus 2 minus ln a minus 1 plus ln a plus 2. And we can, I'm just going to have the third out in the front here so I can continue writing these ln terms. And then we have the second part of this, so plus ln a minus 1 minus ln a plus 2 minus ln 0 minus 1 plus ln 0 plus 2. cancel times by a third. And now, as we can see here, actually some of the terms cancel, such as this first one. You might notice that ln 2 minus 1 is ln 1. The natural logarithm of 1 is just 0, so this term is 0. We have a minus ln a minus 1 here, and we have a plus ln a minus 1 here, so these two cancel with each other. And we have a ln a plus 2 and a minus ln a plus 2, so these also cancel. So what we're left with is a minus ln of minus 1 and a plus ln plus 2 and a minus ln of 4. So let's write out that result. So a third minus ln of 4 minus ln of minus 1 plus ln of 2. Now, as we can see here, we have a ln minus 1, which is not defined. Since it does not cancel out with any of the other terms, this actually means that the original integral diverges. So there is no answer for this integral because it diverges. So that's the answer for this one. Hope you guys learned something. Thank you for watching.